Hello everyone. In this session, we can discuss about Hund's rules. And we all know that the magnetic moment of a material accounts from the spin motion of electron, orbital motion of electron, and spin motion of nucleus. And the main contribution comes from spin motion of electron or spin angular momentum. And in a material there will be a large number of electrons, and these electrons will be paired or unpaired. And paired electrons or electrons in filled shells, their net angular momentum, that is net spin and orbital angular momentum, will be zero because the electrons are paired and the angular momentum gets cancelled. And electrons in unfilled shells or paired electrons, their angular momentum will not be zero. So unpaired electrons or electrons in unfilled shells contribute to the non-zero spin and orbital angular momentum. And Hund's rules, they are used to find the ground state configuration of a magnetic ion. Magnetic materials, as you know, we are considering 3d and 4f electrons. That is 3d electrons, it comes in transition metals, and 4f, as you know, it is rare earth elements. So we are mainly focusing on rare earth elements and transition metals. And Hund's rules are used to find the ground state configuration of a magnetic ion. And ground state configuration, as you know, it is the minimum energy level, minimum energy configuration. So Hund's rules select the angular momentum quantum numbers, or that is orbital and spin angular momentum quantum numbers are combined in such a way to minimize their energy. So as you recall the quantum numbers, that is S is the spin angular momentum quantum number, and its value will be half. And under the application of magnetic field, S will become ms, and it will be having two orientations, plus or minus half. Plus half means upspin and minus half means downspin. And what is L? L is the orbital angular momentum quantum number. It will be having values 0, 1, 2, 3, etc. And L is equal to 0, it is for S electron. L is equal to 1, it is P. 2, it is D. 3, it is F, and so on. And in presence of magnetic field, L will have 2L plus 1 orientations. That is from minus L to plus L, including 0. 0 is also included. So what will be these 2L plus 1 values? Suppose if L is equal to 3, the 2L plus 1 values will be from minus 3, that is minus 3, minus 2, minus 1. 0 is also included, 0 plus 1 plus 2 plus 3. That is L will be having values from minus 3 to plus 3, including 0. So how many values of L? Here you can see 7 values. The 7 comes from 2L plus 1, that is 2 into 3 plus 1 is equal to 7. And another important quantum number is J. This is the total angular momentum quantum number, that is equal to L plus or minus S. And J will always have positive values. It will not be negative. And in presence of magnetic field, J also have 2J plus 1 values. And these values are from L pluses to L minus. That is, consider if total angular momentum quantum number J is equal to 3 by 2, which can come from this configuration L plus S. That is, L is equal to 1, it is a p electron, and S is equal to half means it has only 1 electron. So in presence of magnetic field, how this J will orient? In 2j plus 1 values. 2j plus 1 values. So here how many orientations of j are there? 2 into 3 by 2 plus 1. That is 3 plus 1, 4 orientations are possible. And what are the 4 orientations? That is from minus 3 by 2 to plus 3 by 2 excluding 0. Total angular momentum will not be 0 at any time. So minus 3 by 2 minus half. 0 is not allowed since it is the total angular momentum. There will always be a spin value half, plus half and plus 3 by 2. These are the preliminary things we already know. Now we shall move to Hund's rules. And Hund's rules, we already said, it is the representation of ground state of a magnetic ion. And obviously this ion will be having unpaired electrons, or they are in the incompletely filled shells. And there are 3 rules under this, and these rules are listed according to their preference. That is, we have to satisfy first rule first. After satisfying this first rule, we have to apply the second rule, and then after satisfying both this first and second rule, we have to apply the third rule. So look, what is the first rule? First rule is the electrons should be arranged in such a way that the electron spins add up to give maximum possible S. That is, spin of the electron should be maximized first. What is the first rule? First, we have to maximize the spin value. The electrons are arranged in such a way to maximize the spin value, and this should be inconsistent with Pauli's exclusion principle. And principle, you know, Pauli's exclusion principle is no 2 electrons in a shell can have the same number of same quantum numbers. So by doing this, we will be minimizing the Coulomb repulsion between the electrons. So energy is minimized, which is needed for the ground state configuration. Then after satisfying this rule, what is the second step? The orbital angular momentum should be in such a way that maximum value of L should be taken. That is, first we have maximized S, next we should maximize L. First, spin angular momentum quantum number is maximized, then the electrons are arranged in such a way that maximum value of L is given. Then after satisfying both these, we have to find the value of total angular momentum quantum number. And total angular momentum, we will take it in 3 ways. If the shell is less than half filled, that is, if the shell is less than half filled, the value of J is L minus S. And if the shell is more than half filled, or electrons are more than half filled in the shell, it is J is equal to L plus S. Then if the shell is just half filled, if the shell is just half filled, then J will be S. So if the shell is just half filled, then there L is equal to 0. So J will be L plus or minus S, that is J is equal to S. So after finding this S, L and J, we will write the ground state configuration as. So we have to find S according to Hund's rule, that is first rule. Then L is found according to the second rule, and J is found according to the third rule. And after finding these 3, the ground state configuration of a magnetic ion can be represented as 2s plus 1 L J. So what is this is the representation of a ground state configuration of a magnetic ion. And 2s plus 1, 2s plus 1, this term is called multiplicity, or we can say it as spin multiplicity. And L is the letter and it represent the symbol, that is, if L is equal to 0, we write it as S, and if L is equal to 1, we write it as P, 2 D, 3 F, if it is 4, it will be G, H, I, and so on. 5, 6. So 2s plus 1 will be a number. It is the spin multiplicity. That is, the value of s we have to substitute here, and we will get 2s plus 1. It is written in the left top portion, and L is the symbol according to this conditions, and J, which is written in the bottom right, that will be the J value obtained in the third rule, that is L minus S if it is less than half filled, L plus S if it is more than half filled, and S if it is just half filled. Now we can find the ground state configuration of a rare earth element, that is dysprosium 3 plus ion. And dysprosium, if we write the electronic configuration according to the form 1s2, 2s2, 2p6, 3s2, at last the unpaired electrons or unfilled shell is 4f9. And you know, the rare earth element, the magnetism comes from this 4f shells. And what are the features of 4f shells? Since it is f shell, its L value is 3. And since it is L value is 3, what are the possible orientations? There will be 12 plus 1 values, that is 2 into 3 plus 1, 7 orientations are allowed. That is from minus 3, minus 2, minus 1, 0, 1, 2, 3. That is, there are 7 subshells for this F electron. And how many electrons are in the outermost shell or valence shell? There is 9 electrons. 9 electrons in the 4f shell, and we can see how these 9 electrons are filled. 9 electrons are filled. So what are the Hund's rules? First Hund's rule, you remember, we have to arrange the electrons according to Pauli's exclusion principle, and so as to get a maximum value of S. That is, total S should be a maximum value. For that, how the electrons will be accommodated in these shells? So there are 9 electrons and there are 7 subshells. So in these 7 subshells, 1 electron will be accommodated in each shell, and it will be having upspin. That is, 1 electron in Ml is equal to 3, another electron in 2, in 1, 0, minus 1, minus 2, and minus 3. That is, 7 electrons were filled, and remaining there are 2 electrons. So they will be filled in the first 2 levels, that is in 3 and 2. Is it clear? That is, there are 9 electrons in the valence shell, and from the first rule we have to arrange the electrons in such a way to get a maximum value of S. For that, electrons should be arranged in this manner. That is, 7 electrons should be accommodated in the upspin level, and the remaining 2 electrons in the downspin level of the first 2 subshells. If we arrange electrons only in this way, we get the maximum value of S. In any other combinations, S will be not the maximum value. And it should obey the Pauli's exclusion principle too. That is, here no 2 electrons in the same state. Here, for Ml is equal to 3 level, one electron is in up state and other electron is in the down state, even though Ml value is same. Even though Ml value is same, Ml value is equal to 3 for both these electrons. Their spin values are different. One spin is up and one spin is down. So what will be the S value? what will be the S value. These 7 electrons, they will be having up spin. So its spin is 7 into plus half. And these 2 electrons will be having minus spin. So their spin is 2 into half, which is minus. So what is the total value of S here? So S will be 7 by 2 minus 5 by 2. Right? And that will be 5 by 2. Clear? So we have find the first condition, that is maximize the value of S, and we got the maximum value of S for this dysprosium 3 plus ion as 5 by 2. And we have to arrange the 9 electrons in such a way that its value of S should be maximum. For that, this type of arrangement is needed. So we have maximized S. And what is the second rule? Second rule is, after maximizing S, we have to maximize L. That is orbital angular momentum quantum number. It should be maximized. So S we have maximized, and the value of S is 5 by 2. And the value of L, what will be the value of L? We have to add all these ml values. And for these 7 up electrons, these 7 electrons which are in the up state, what is the total value of ml? 3 plus 2 plus 1 plus 0 plus minus 1 plus minus 2 plus minus 3. That is the upspin values, its angular momentum or total L value is 0. And for downspin, so upspin, total ml is equal to 0. And for downspin, what is total ml? Total ml is equal to 3 plus 2. 3 plus 2. 3 plus 2, that is equal to 5. So the maximum value of L. L is also we have found L and S. Next we have to find J. So what is J? J is equal to L plus S or L minus S, or it is simply S. So in this ion, as we know, this F shell, it can accommodate 14 electrons, and here it is having 9 electrons. So it is more than 7, that is, it is more than half filled. So we have to apply which rule? J is equal to L plus S if a shell is more than half filled. So applying this, what we get? It is S we have found as 5 by 2, L as 5. So J will be modulus of 5 plus 5 by 2, that is 15 by 2. So we have found all the 3 terms. So how to represent the ground state configuration of dysprosium? 2s plus 1 L J. So what is 2s plus 1? It is 15 by 2. And what is L? L is equal to 5. So L is equal to 5 corresponds to which symbol? L is equal to 5 corresponds to L is equal to 5, it corresponds to H. So 15 H. And what was J? What was J? Sorry, the value of J was 15 by 2. In the top left, we have to write 2s plus 1, that is multiplicity. So the value of S was 5 by 2. So 2 into 5 by 2 plus 1, it is 6. So in the top left, we have to write 6. So 6H 15 by 2. 6H 15 by 2 is the ground state configuration of a dysprosium 3 plus ion, whose shell is unpaired shell is 4 of 9. This is how we can represent the ground state configuration of a magnetic ion using Hund's rules. So remember, this 6 is the spin multiplicity, H is the symbol, then 15 by 2 is the J value. Hope everyone understood about these rules and how to represent the configuration. Thanks to all.